Hey YouTube, Hyperius here again. So I took the 6,000 watt Beastmobile and put it all into this frame. This is the electric enduro frame. You can get them for about 500 bucks or so shipped from eBay. As you can notice, I also replaced most of the other components, kept the motor the same. I replaced the controller with a 3,000 watt capable one that I then beefed up the shunts on to be able to push 7,000 watts. So this thing should be doing around 7 kilowatts right now. Motor is still the HS6045 Taillight hub, and then I've got new tires that I'm going to be putting on the back. Eventually I'm going to be shifting this to a Delta Y sign configuration so that I'll be able to switch on the fly. That should allow me the low-end torque I need to get up hills and then the high-end speed to keep up with traffic. Eventually I also want to replace the seat with the enduro bike seat. Looks more like a motorcycle seat. I'll probably post a picture in the bottom corner here just to show you what it looks like. So let's go ahead and I'll do a tour of the internals on this thing as well to show you what's going on. They're not fully finished yet because I still need to get the 12 volt step-down, DC-DC step-down transformer to be able to run the lights and various other little things I want to attach to it, like a USB plug for charging phones and that kind of thing. But once I get that in, it should be basically complete. As it is now, I do not have onboard charging, but I do have a separate charger that it comes with. The battery I bought comes with a separate charger because it has a BMS on board. But when I open it up, I'll kind of explain that more further. Okay, so I've got this thing popped open now, so let's do a tour of the internals. So as you can see, it's somewhat cramped. Once I get the transformer in, I plan on cleaning up a ton of these wires because most of them are coming from the Sunwind controller I have down here, the one that's rated for 3,000 but have been beefed up to about 7 kilowatts. Up top, going through there, I have a KT03 LCD that does the controlling of the motor controller. I really like this one because honestly it just works out of the box with the controller. No real dicking around with wiring of the cycle analyst like I had before. The only problem is you just need to turn it on whenever you put the key on, but that's not too much of an issue. Additionally, I also have a voltage meter, 3D printed kind of housing for it so that it would mount on the handlebars, and then I can view my voltage live while I'm riding. So on this battery pack, there is a bit of a voltage sag when you go full throttle on the motor, but that's to be expected. This is the 20 amp hour Life PO4 pack from Sun e-bike. They're a Chinese supplier. Got it from Alibaba, about 550 shipped. So far I've done range testing on it. I'm getting about 35 miles or so of full charge. So I'm able to do, my normal runs up and down the valley here where I live. It's not too much of a problem really on range anxiety. And in addition, I can just bring the charger with it in my backpack and plug in wherever I find a outlet. The one thing about this battery is that they have a BMS on board, which is really nice for charging, so I don't have to worry about equalizing all the cells. The problem with the BMS is it's current limited at 50 amps. I know for a fact this battery uses headway cells because when I disassembled it to rewire the BMS, I actually checked the tagging on the cells that were inside, and all of them were headway cells that should be rated up to 80 amps apiece. So there are 24 cells in a 72 volt pack, but this one has 24 10 amp cells in series and then 2 parallel side by side. So you get 20 amp hours 24S Life PO4. So what that enables me is if they're pulling 70, 80 amps a piece, I'm able to get 140 amps out of the entire pack, which is significantly more than the BMS quote-unquote handles. So I kind of routed around the BMS by tying the output for the ground cable directly to the ground in on the BMS. So the way that the charging works is the charging goes through the BMS and charges each cell individually, but when I draw power for the motor or for the load, it draws directly from the battery instead of routing through the BMS. Because when I originally had this battery in and I was just messing around with it for the first couple days, I was constantly triggering the current limiter because that BMS is only limited at 50 amps. And because this controller is pulling well over that, I'd say probably around 90 to 100 amps, it was constantly popping off even if I just slightly rolled on the throttle. Now though, it's just a smooth, even throttle, and the thing I like about Life PL4 batteries is they have even power delivery. On LiPo, you used to be able to just mash the throttle and the thing would just accelerate like crazy and you would probably pop it up on one wheel. Thankfully with this, it just smoothly accelerates and it's really predictable throttle curve. So currently I have on top a socket for a car charger, like a car USB charger thing that you can put in here. This is my light switch. Unfortunately, I didn't really measure it very well, so it's kind of obscured here by the LCD, but what's cool is I can just press down on the LCD and it bends it and pushes the light back. Up front, I got a 10,000 lumen, basically a motorcycle lamp, and that's good for riding at night and be able to see literally anything in front of me as well as more cars. The next thing I've got to do is wire up a motorcycle tail light, especially if I want to replace the seat here, because the biggest thing about this is once I replace the seat, it's not going to look like a bike at all anymore. It's going to look more like a dual sport enduro bike. And once that happens, cops are going to give me the eye the entire time I'm riding it. So better safe than sorry if I have lights on there. Inside, again, we have this tangled hornet's nest of wires, but most of these wires are for the 12 volt side. There's only a couple of them in there that are for the actual powering of the motor and everything. This is my main phase cables. I actually used, what is this, like a 10 gauge or something like that, 10 gauge cable that you use for underground outdooring lighting. So if you like have a outdoor kitchen and you want to set up all the lights for it, this is what you would run underground. So it's armored, which is nice. So it runs all the way to the back to the motor. As well as I use Cat 6 for the Hall sensing cables, as well as the temperature cable on the motor, which is also pretty nice because Cat 6 gives you enough overhead to be able to plug in any cables you want on it. The one thing I do need to do is, like I said, kind of chop up all the cables that are coming out of the motor controller, because there's really only like 5 cables I'm using out of that. You got the phase cables, Hall cables, the regen, and the LCD screen, which the LCD screen forwards the throttle control. So I really only need like 5 cables out of it, but as you can see, it comes with like 30. So I probably got to chop that up when I get the new 12 volt DC-DC converter to put in there. Additionally, on the 12 volt side in here, I have a little like Hella horn. Hella is the brand, and that's kind of a motorcycle horn, and honestly I just put it in there because where I ride is mostly on trails or I ride on street, and as you can tell with the hookworm tires, I don't normally take this thing off-road. This thing is meant to be kind of a commuter. So by having a horn on it, I'm able to get away with going through traffic where normally it would be kind of dangerous for a bike. New Hella 26-inch tire up front. I got that replaced when I replaced the D&M shocks, because I had originally put the Fox fork I have on another bike on here, but it just wasn't tall enough, so I had this weird thing where the nose of the bike was angled down, and it caused a problem where, because the head tube was essentially vertical, anytime you pull too much steering, it would lock up and spin you out, and you'd go end over end. I hate it pretty good doing that, so I was like, okay, I need to increase my my head tube angle, so I raised up the fork by getting a downhill fork, which from D&M, which is, I mean, they're cheap downhill forks, but honestly, I'm not going to be doing any heavy downhilling, so really, it's just nice to have a beefy fork for the extra weight that this bike has, because it's not light, just to put it lightly. Thing is probably, with battery, about 150 pounds. which is entering the realm of motorcycle. Anyway, up front I've just got Shimano crankset, literally ghettoed together with a couple washers to be able to put the Shimano little crank on the outside instead of the inside of the crank. That way the chain is more tight. I still have to use a chain tensioner, which is basically on its last rung because the chain is so long. But with that chain tensioner, I only normally get a derailment if I really hit a heavy bump and start pedaling backwards. Anything pedaling normal is fine. On the back side of the motor here, you can see I actually drilled some holes for air vents. Additionally, I also 3D printed some little scoops so that when the motor is spinning this way, in a circle like that, the scoops actually scoop air and force it through the motor, and then the air exits the holes without scoops. I've gotten some comments from people saying, oh, well, if you're not moving fast enough, what's going to happen is you're going to create a suction from the bottom one in the retreating direction and a positive force from the top one as it slices through the air, kind of like a helicopter when it's moving at high speed, where the lift on one side diminishes because it's retreating from the speed of the advance of the aircraft. There is a truth to that. You do get less input from the bottom one here of air rushing in, but honestly, for the speed and the RPM this motor is running at, it doesn't really make a difference. I mean, maximum speed this motor is going to be pushing maybe 2,000 RPM. I mean, at 2,000 RPM, you're not going to be putting much air in anyways, so, or you're not going to be pulling much air in from the back anyways, so I really figure that it's better to just have the scoops there to force air in any way it can. I just have some Radio Shack 6-pin connectors for the hall sensors here, as well as bullet connectors for the phase wires. That way I can disconnect them easily and replace the tire or do maintenance on the motor or whatever I need to do here. Eventually, like I said, I'm going to be rewiring this motor to do delta Y switching, so that way I can do on-the-fly switching for high speed or high torque. I cut out a little hole behind the seat post here, and then I put a 12-volt DC fan, like a case fan for a computer, so I can cool the motor or cool the battery when I'm just sitting at a traffic light or something like that. Because one thing I do notice is this battery gets a little bit warm, but not warm enough to be a problem. I guess that's just a feature of LifePo. LifePo batteries just get a little tiny bit warm, but it usually dissipates the heat extremely easy. I mean, other than that, that's pretty much the standard build for this thing. As it is now, I do not have a rear disc or rear brake, and that's because I set up regen on this thing to be extremely strong. So if I just touch the little button I have here, which is actually a Suzuki motocross kill switch for a motocross bike, but if I just touch that little button there, the back tire almost locks up from the amount of regen, and it's really dependent as a function of speed. So the faster I'm going, the harder the regen is. Additionally, it's a function of weight. So what's cool is when I was testing this bike with the testing batteries that just had Turnigy 4-cell lipos in it, those weighed almost nothing, and the bike would literally lock up the back tire if you were going too fast and hit the regen. Now with the extra weight of the larger battery, the back tire doesn't lock up nearly as much unless you go over a bump, but you get significant amounts of power back. Like, I'm getting a good 15 to 20% of the power I put in on acceleration back, maybe like 50 or 60 amps back into the motor and back into the battery anytime I hit the button. But it's an exponential curve, so the faster I'm going, the more power I get back, whereas with the front brake, it's just heat dissipation. But on the front brake, I actually have a Shimano hydraulic up front. It's kind of the cheapest one I could find on eBay. This is actually supposed to be for the rear brake here, but I had to use the rear brake one because the tube for the hydraulic was just long enough to go all the way down to the rear brake. If I hadn't have used that, and I used the original one that's made for a front brake, it wouldn't have been long enough, and I would have been like stretching it like crazy in order to make it. And I wanted it on this side because on a motorcycle, the front brake is on this side anyways, so it just kind of makes sense. Yeah, like I said, I'm going to be replacing the back tire, which is a Kenda K-Rad right now. I'm going to be replacing it with a hookworm, but I figure I'll do that once A, it's been completely rubbed down to the nub, and then B, when I want to get the delta sign switching set up, because I'll be able to pull the motor off, do kill two birds with one stone, two things at once. But other than that, that's pretty much the build I have currently. Like I said, just charges in my garage here off of a Sun's e-bike 72 volt charger. And what's nice is you can throw this in your backpack, and it's a standard outlet. You can just plug it in anywhere and charge up your bike. Rode 30 miles yesterday to a movie theater down the street, or 30 miles down the road from my house. Plugged it in behind the movie theater where it was kind of hidden, and then let it charge while I was down there, and almost had full battery by the time I was done. So, yep, 30 miles, top speed around 45 miles an hour, charge times maybe 4 hours from 0 to max. So that's my build.